Yes, so next let's move on to few examples. Okay, so actually I will tell 10 examples. So these are very important, and I prefer that you remember all the final answers. Okay, right. So first one, let us take x of t to be equal to how much? E power minus at u of t. So we are interested in finding the Fourier transform of the signal. Okay, so if you try to plot this signal, so note that we want to find the Fourier transform, so definitely x of t should be absolutely integrable, and hence how should the plot look? It should look like this. So for the plot to look like this, what should be the value of a? The value of a should be greater than 0. Okay, if the value of a is greater than 0, our signal x of t would be absolutely integrable. So here I assumed that a is some real number. Okay, but a can be complex also. We'll take an example to show that. Okay, so let us try to find Fourier transform of this signal. Okay, yes, so what is that? Let me call this as x1 of t. Okay, and the corresponding plot is this. So let us find its Fourier transform, which is x1 of j omega, which is equal to, actually integral should be from where to where? It should be from minus infinity to infinity, but the signal exists only from 0 to infinity. So and hence we have to use x of t, which is e power minus at multiplied with e power minus j omega t dt. Okay, so this is the way how we define the Fourier transform of a signal. So definitely for this to exist, x of t, x1 of t should be absolutely integrable, and for that to happen, a should be greater than 0. Okay, so this integral we can write it as integral 0 to infinity. By taking common terms, you will get minus of a plus j omega t dt. Okay, so this should be equal to how much? This would be equal to exponential terms. Integral would be, you will get e power minus of a plus j omega t divided by minus of a plus j omega, and integral limits are from where to where? 0 to infinity. So this should be equal to how much here? Because a is greater than 0, if you substitute t with infinity, you will get e power minus infinity, and hence you will get 0. Okay, so 0 minus, when you substitute t with 0, you will get 1 by minus, so you will get minus 1 by a plus j omega. Okay, yes, so finally this should be equal to how much? This should be equal to 1 by a plus j omega. So that would be the Fourier transform of the given signal. Okay, so let me write down. So this signal will have what as Fourier transform? x1 of j omega, which is equal to 1 by a plus j omega. Okay, note that we are not talking anything about a. Okay, a can be real, a can be complex, but for understanding purpose, I mean to plot the signal, I took a to be real number, and that should be greater than 0. Okay, what happens if a is complex? That we will see with an example. Okay, so again note that this is our x1 of j omega. So x1 of j omega we got to be how much? 1 by a plus j omega. So this can be written as what here? So that can be written as, so if you multiply and divide with a minus j omega, you will get a minus j omega divided by a squared plus omega square. Correct. So if you multiply and divide with a minus j omega, you will get a minus j omega by a squared plus omega square, which is nothing but a by a squared plus omega square minus j omega divided by a squared plus omega square. So clearly this implies what? The real part of j omega is equal to how much? A by a squared plus omega square, and imaginary part of, okay, xr1 let me call, okay, because we are talking about x1 of j omega. So I1 of j omega would be minus omega divided by a squared plus omega squared. Okay, this is as far as real and imaginary parts are concerned. But if you want to write in terms of magnitude, so you have to find out modulus of x1 of j omega. So that should be equal to how much here? X1 of j omega is 1 by a plus j omega. This is looking like 1 by z, correct? A plus j omega is a complex number. So modulus, if you take, you will get 1 by modulus of z, which should be root of a squared plus omega squared. So you will get what? Modulus of x1 of j omega would be equal to 1 by root of a square plus omega square. And what happens to the angle? Angle of x1 of j omega. So this turns out to be how much here? Just now we have seen. So what is angle of x1? Previously, in previous lecture we have seen angle of x1 of j omega is how much? Tan inverse of imaginary part by real part, correct? So tan inverse of imaginary part by real part. Imaginary part is how much? Minus omega by a squared plus omega square. By real part is a by a squared plus omega square. So clearly a squared plus omega square will get cancelled. We will get tan inverse of omega minus omega by a. So that would be the angle of x1 of j omega. Now for this example, let us for this question, let us take an example. Okay, so find CTFT of, let us take first question, which is e power minus 2t u of t. Okay, so clearly because a is a real number and because it is greater than 0, definitely this fellow will have what as Fourier transform? 1 by a plus j omega, we will get 1 by 2 plus j omega. You can find out real part, imaginary part, magnitude and angle. Okay, I will leave it to you. Next, so let us take second example, which is e power minus of 3 plus 2j into t. So what about this function here? Will this fellow have Fourier transform? That is the question. So for this signal to have Fourier transform, what is the condition? This fellow should be absolutely integrable. So let us try to find out. I'll take u of t. I forgot that. Okay. So it is e power minus of 3 plus 2j multiplied with t. So we have to find out whether this fellow is absolutely integrable or not. So we have to take modulus of this function. Because of u of t, the integral limits will be from 0 to infinity. Modulus of e power minus of 3 plus 2j into t dt. Okay, so this should be equal to how much? Because okay, so I will write down integral 0 to infinity. So this can be written as modulus of e power minus 3t multiplied with modulus of e power minus 2jt, okay, and dt. Correct. So if you take modulus, you have to split. Okay, but if you look at this, modulus of e power minus 2jt is looking like mod of e power j theta. So this modulus would be equal to 1. So this should be equal to integral 0 to infinity, because e power minus 3t is always positive. You can remove the modulus. You will get e power minus 3t and this flow is 1 dt. So clearly this you can simplify to be how much? 1 by 3, and because this flow is finite number, our signal will have Fourier transform. And how much is that here? It is again looking like what? E power minus at u of t. So definitely what is the Fourier transform? That should be 1 by a plus j omega. A is how much? 3 plus 2j, correct? Plus j omega. That would be the Fourier transform, or you can write it as 1 by 3 plus j times omega plus 2. That would be the Fourier transform of this signal. Okay, which is e power minus of 3 plus 2j into t. Okay, similarly we'll take one more example, I mean two more examples, third one. Okay, so let us take e power 3t u of t. Okay, what about this signal? Will this fellow has Fourier transform? Be careful, you may be tempting to write that it is 1 by 3 plus j omega or 1 by minus 3 plus j omega. No. Why? Because first condition, what is that you have to check? Is it absolutely integrable? You have to check. So what is that? Integral 0 to infinity modulus of e power 3t, as we said it is e power 3t dt. Okay, I'll put modulus. So this is equal to how much? Infinite. So clearly this fellow is not finite number, and hence what do we say? Fourier transform does not exist for this signal. Okay, be careful. Okay, CTFT does not exist. Okay, why? It does not satisfy our first Dirichlet condition. Okay, right. So as a final example, we'll take fourth one, which is, let's say, e power 2 plus j times t u of t. What about this signal here? Will this have Fourier transform? So again we have to check whether it is absolutely integrable or not. So integral, because of u of t you have 0 to infinity. So if you take modulus, I'll skip few steps. So we will get e power 2t dt, correct? Because of u of t, integral limits will be from 0 to infinity. If you take modulus, what happens? You will get e power 2t multiplied with modulus of e power jt, which is equal to 1, and hence you get this. You can easily see that this is again equal to infinity, and hence because it is not satisfying first Dirichlet condition, this signal also will not have Fourier transform. So in that way you should be careful. Every time if somebody asks you to find the Fourier transform, what is the first thing you have to do? You have to check whether the signal is absolutely integrable or not. Okay, so CTFT does not exist. Okay.